Welcome to Interesting People. My name is Tom Lorentzen. I'm the host of the show. This program is brought to you under the auspices of the Chabot Los Positos Community College District at the studios at Chabot College here in Hayward, California. The premise of this show is that there are interesting people everywhere. Everybody's family, everybody's neighborhood, and that our country, and indeed the world, is rich with interesting people. In prior interviews, I've done some people that have also known. Sander Van Oker, the last living member of the Kennedy-Nixon debates and a prominent newscaster, Dr. Eve Engelman, the oldest known practicing physician in the world at 104, who sadly has now passed away. But recently, I went on the 50th anniversary of the launching of Apollo 11 on the U.S. aircraft carrier, the USS Hornet, which is permanently docked in Alameda, California. And while on the ship, I met a couple of young ladies who are working for a contractor and involved with NASA. And I thought, wow, these two individuals are really interesting. And they're only in their early 20s. But I recalled a conversation. I had a friend from high school when he went to work for Lawrence Livermore. And Dr. Edward Teller, the famous theoretical physicist, came to see my friend when he was in his late 20s, right out of college with a PhD. And he wanted to pick his brain. And here was a world-renowned physicist. And he wanted to pick the brain of this young man named Alan. So that's why I invited these two ladies to come on the show, because I'd like to pick your brains. Welcome to Interesting People. Thank you, Jordan. Elizabeth.
Thank you.
So welcome to the program here. We're going to start with you, Jordan. Tell the audience and tell me a little bit about your background and where you went to school and how you got involved in this whole world of science and with NASA.
Yeah, absolutely. So I grew up in Heartland, Michigan, which is a small town outside of Detroit, and I went to the University of Michigan for college, where I studied biology and international studies. And I've always been really interested in science and learning about the natural world and just kind of figuring out why things are the way that they are. And I always really liked biology, so I planned on studying that when I went into college. And actually, when I was a freshman in college, I kind of by chance stumbled across this thing called astrobiology, which was searching for life on other planets and thinking about how life from Earth could actually be spread out into space. And I didn't know that field had existed, and throughout college I tried to get involved with it, and that was what led me to apply to an internship program at NASA Ames Research Center out here in California, Silicon Valley.
Holy cow. Well, when I was a kid, we all called this science fiction. Now it's in practice. It's amazing. And Elizabeth, tell us about yourself, where you're from and your educational background and how you ended up involved at NASA in the capacity you are.
I was born in San Jose, California. Originally, I went to college at Santa Clara University studying bioengineering, and then I transferred to Embry-Riddle Aeronautical University, where I'm finishing up my degree in engineering with a minor in mathematics. I think I've always been interested in math and science. My mom actually taught my sister and I multiplication when we were in kindergarten or first grade. She put up a multiplication table in the pantry door, so whenever we would want a snack, we'd have to do multiplication before we could get our food.
Holy cow.
And I think being familiar with math at a young age made me more comfortable with it as I got older, just because I'd been exposed to it since I was a little kid. And it might have helped that my dad was a big fan of Star Trek, so I grew up kind of in that world of science fiction and being inspired by that. And I think that has definitely influenced my career and being interested in engineering. And I actually stumbled across an internship with NASA by chance also. I had a classmate who had this really interesting sticker on her laptop. It said Space Biosciences Division, and I had no idea what that was. So I Googled it instead of paying attention in class, and I found that NASA Ames Research Center in Silicon Valley did a lot of biological research, and I found an internship that I applied to, and I started off as an unpaid intern, and I've been trying to come back every summer since.
Well, now your roles at NASA, you work for, or you're engaged with somebody else. What's the contractor?
KBR.
And what is KBR, and are you also?
Yes, I'm also KBR.
So you're basically sort of on loan through an internship to NASA? Is that sort of what it is?
Yeah, so NASA brings a lot of people to work at their centers by hiring people through government contractors. KBR is one of them. So we work technically for KBR, but we work at NASA on NASA projects.
And you're at Moffett Field over here in Sunnyvale. Give me and give our audience here a little bit of background on Moffett Field from what you've learned. How far back does Moffett Field go?
Yeah, absolutely. So Moffett Field has been around since the early 1900s, back when NACA was established, which was the National Advisory Committee for Aeronautics. And as the need for actually a presence in space became more pronounced, NACA became NASA, and Moffett Field and the research going on there became NASA's Ames Research Center.
Oh,
Yeah, it's very interesting. You could walk around NASA Ames and see buildings that still say NACA on them.
Really?
Yeah,
But then NACA was done away with when NASA was created.
Yes.
that's correct. Yeah.
And as we were discussing before the show, what president, under what president was NASA created?
Eisenhower.
Eisenhower.
There we go. There we go. Now, I want to bring up the term STEM: science, technology, engineering, mathematics. Right? Are you products of that type of an initiative, or are you just products like with your mom that you were trained from the time you were a little kid to go into math and science, or tell us how you got into this whole world?
Yeah, I think the STEM initiative was encouraging to continue on to this path. Having an interest in science and math, and being young, I didn't know exactly what I could apply that in because there's so many different careers that you could enter. But the STEM initiative and the STEM label being advertised through internships so heavily was a big motivator. There was something that I could strive for, some field that I wanted to break into that sounded very promising. There's a lot that you hear in the news about careers in STEM and development in STEM. So having heard that term a lot, it was a good motivator. Like, maybe there's something there for me. Maybe I can do that. I like science. I like math. I want to develop new technology. I should probably look into a STEM career.
You like science and math. All the people I grew up with, none of us like science and math. Is there something wrong with you?
Probably.
Were you that way too, interested in science and math?
I was very interested in science, yes. As far as math, that wasn't really my favorite subject in school. And I remember thinking when I was younger, oh, how could I be a scientist if I don't like math that much? And as I grew up, I kind of realized that math is very important, but it is not the only thing that makes a good scientist. And so bringing in other things that can go along with people who are interested in math, but you also don't have to be interested in math to be curious or to be creative. And those were things that I found to be really helpful as I went through the STEM field.
Well, when I was in college, I majored in political science and history, and I minimized taking anything in math and science because I was not good at it. I didn't understand it. So help educate me now, and maybe others like myself who know so little about this area. With mathematics, where do you feel mathematics fits in the role of science? Is it a matter of helping to train logic or calculations or everything?
Yeah, all of those things. Mathematics is a really great way just to understand the world around us and the laws that govern it. And at the end of the day, it really is really helpful for logic and for making decisions, for quantifying things, and it's really, really useful to know.
Mm-hmm.
Now, I have to acknowledge, when I was in high school, I got through algebra. Geometry I didn't do too good in. So, Elizabeth, what's your mathematical background? Did you go beyond algebra? That's as far as I got.
Yeah, so I finished the calculus series. I've taken differential equations, linear algebra. My minor is actually in math, so I've done a lot of advanced math. And I think it's important for science for a lot of the computational models. So with aerospace, I took an aerodynamics class, and we were doing a lot of the calculations for lift and drag by hand, but now you have simulations that you can run. So you can model a wing through a computer and then test how that wing would act based on the equations that are associated with the speed, the type of atmosphere that the airplane is going through or aircraft is going through. And you can get an accurate representation of how it would behave solely based on math and physics. And I think that's really interesting and useful.
Yeah. Elaborate a little bit more, if you can, Jordan, on your mathematical. You weren't that interested in math, but you did. So what?
Yeah.
Tell me, what beyond algebra have you done? And that's as far as I ever got.
Mm-hmm. I took preliminary calculus, Calculus 1, and I took statistics. And so it was definitely really helpful in my career as a biologist to have that background in quantitative analysis.
Mm-hmm. When I met both of you on the USS Hornet 2, they did a lot. They had some computers and everything, but a lot of it was more the old way of doing things. What strikes you looking back a little bit on Apollo 11, 50 years ago? You weren't born yet, and technology and science at that time. And what thoughts came to you as you were on the Hornet looking at that historic event 50 years ago?
Yeah, I think I was really just blown away by how incredible of an achievement we were able to do with the computational power that we had at the time. Like, everyone loves to say now that the technology that brought us to the moon is comparable to the technology that's in a cell phone today. And that just really makes me think about how much power we have at our hands and what incredible things can be done. And now this technology is in everyone's pockets. So it's really inspiring to think about what people can accomplish.
What thoughts did you have on the Hornet when we just met about 3 weeks ago, I believe? To be there and to see that historic anniversary?
It was surreal, and I thought a lot about the people in the background that did these calculations by hand. I think we take for granted a lot now how much we can get done on a computer, or the different algorithms and technology that we have now, whereas back then they had people who were the computers doing those math equations, having to check them, and I think that's incredible, inspiring. Sometimes when I'm doing my homework, I'll get caught up on a problem or on an equation and be frustrated with it, and I take for granted how much of that was actually done by hand before. And Jordan and I were talking about that, how sometimes being in the context of these great historical events can inspire you in your own career, because it's very easy to get caught up in the weeds of coursework or day-to-day activities, and when you see pieces from these great historical events, you could see how beautiful the meadow is. And yeah, I think it was an inspiring event.
On the inspiration there, I'm not a terribly adventurous person. If somebody was going to come to me and say, Tom, would you get in this thing and go out there, I would have said, no way. In addition to the mathematics, the science, the engineering, what do you think, looking back on people like Neil Armstrong and the other individuals that were, Alan Shepard was the first person that the United States sent into outer space. What do you think of when you think of individuals like that? What motivated them? Were they just wild and crazy people, or were they pioneers, or what were they? Do you have any thoughts?
I think they're inspiring. I'm not sure how they had the nerve to get in this little metal base, I guess, little tin can and be shot up into the atmosphere. I don't know how comfortable I would be with that. We went to Edwards Air Force Base to tour there for our program, and there was a comment made about how the people that we chose to send to the moon were level-headed in times of stress, and that was kind of why they were chosen.
Sure.
So I would imagine that they'd have to be incredibly brave and also incredibly calm.
Yes. Yeah, it amazes me. I mean, I think twice about even getting my car and driving across town now, and but these individuals that were willing to take the chances. But I think about the same thing when people took the voyages of exploration to go across the ocean. I take one look at the ocean with those old little ships and say, my God, they got in those things and went across the ocean. And I look at these astronauts and what they did going into outer space. So it is rather miraculous. And what we're going to do now, Jordan, Elizabeth, we're going to take a brief pause, and we're going to have a public service announcement, and then come back to our discussion here, and we're going to follow up on some of the things that we've talked about and some things we haven't talked about.
You can achieve a lot using your imagination. I mean, I don't like to brag, but... Wait, who's that? And why is she all over these achievement awards? But with STEM, the sky's the limit. Shaboom! Use STEM to envision. Okay, I'm seeing it. Yeah. Invent.
Got any ideas?
I've got a few, actually. And create a better world.
Told you she's super smart.
If she can STEM, so can you. Find out more at She Can STEM.
Welcome back to Interesting People. My name's Tom Lorentzen, the host of the show. And with my guests today, Jordan McKaig and Elizabeth Talburt. Both young individuals who are already experts in the world of science and mathematics and other things. type of things that I don't know much about, and probably a lot of you don't know that much about. So we're here to pick their brains about what they're experiencing, what they see, including not only the present, but for the future. So before we go into some of the things, I'd like to ask both of you to elaborate a little bit more. You referenced earlier the program you're in. You're working for a private contractor, basically on loan or detailed to NASA. Tell us a little bit more for the audience and myself about that program and what type of experiences you have, the things you do, and what you're learning there. So why don't you go first, Jordan?
Sure. So we actually met each other last summer. We were both participants in the Space Life Sciences Training Program, which is an internship for space biosciences that brings students to NASA's Ames Research Center, and they all work together on a variety of investigations that are space biology relevant. And every year they bring back 2 people to be program coordinators, and so that's what Elizabeth and I are doing.
So anything you'd like to add to that, Elizabeth?
We have a variety of responsibilities in this program. So 50% of our time is spent on individual research, and the other 50% of our time we're coordinating events, networking tours for the students that are participating in this program.
I see. By the way, to those of you in our viewing audience here, I sort of have a title that I sort of created for this interview, if I can find it here. I'm calling it Youth and Science in Outer Space 2019 and Beyond. And again, at my age now, 73, I remember when Sputnik first went up in October of 1957. I remember when all the explorations in space were taking place, and of course when we first landed on the moon. So, in trying to learn things from your perspective now looking forward, but you know, they both kindly shared with me their resumes. And again, expressing my lack of knowledge. I'm no Dr. Edward Teller. I'm not good with science and math. But you've done some amazing things already, and you're only 22 and you're 23. So I'm going to turn to you, Elizabeth. I'm going to ask you some questions here about what you've already done, and I hope I can understand something that you're going to say. So here's something. She's been involved in automating, optimizing, and tailoring a system to be microgravity compatible for usage on the International Space Station. So Elizabeth, what is that all about?
So microgravity is what people refer to as the space environment. So instead of zero gravity or zero G, we like to call it microgravity because there's still a little bit of gravity there.
Okay.
And with that, you run into issues with fluid dynamics, how things flow in tubes. You get a lot of bubbles. And with a lot of laboratory work that we do on Earth, we take for granted how much of it is gravity assisted. So if you're doing, say, a DNA extraction or an RNA extraction, you're moving a lot of liquids from one tube to another, doing wash steps to try to purify your end product. And to do that, your liquid needs to stay in the tube. But if you're out in space, your liquid's going to want to fly around and not play nice and stay in your tube. So when you're designing systems that are going to the International Space Station or in the future to Lunar Gateway, you have to keep in mind the fluid physics of the space environment. And so that's a little bit of what I'm working on this summer is to help design and automate and optimize a laboratory procedure that is microgravity compatible, so that could be used in the future for research that's being conducted in space.
Well, I don't know about you folks out there watching this show, but I never heard of the term microgravity before, so I just learned something new, and you explained it in a way I think I understand what you're talking about. I'm going to ask you another question then. You, on here, you've conducted research investigating the mechanical signaling pathways in
Mesenchymal.
Mesenchymal. Okay. In mesenchymal stem cells and the response to irradiation. Again, what is that? What's this all about?
So mesenchymal stem cells are types of cells that could turn into bone, fat, muscle tissue, and they're sensitive to mechanical signaling. So if you have something pulling on that cell, then it'll activate different pathways, and that can determine whether it goes to bone or to muscle or to fat generation. And so my project was to look at these mechanically sensitive pathways that would be affected by going into space, because you don't have the pull of gravity on your body, so you're losing that mechanical signal. So we wanted to see, with these mechanical signals being affected, how would they respond to irradiation? Because when you're in the space environment, you are exposed to radiation from the sun or from particles that are flying by in space, and we want to know if those signaling pathways are affected by radiation.
So is it again, me as a naive person who knows little about this, does gravity one way or another affect most everything, whether it's physical or electronic waves and things like that? Is gravity the central force that impacts most everything?
Yes, gravity affects a lot, especially biological systems. So with people exploring space and further into space than we've gone before, that's definitely something that we need to consider. And so it's important to do this type of work to make sure that if there's people going out into space for long periods of time, that when they come back to Earth, they'll be okay.
I'm going to go out on a limb. Is there relevance on this to medical research and health here on Earth,
Yes.
where we're under normal gravity? Any thoughts you can share on that?
Yes, so a lot of the mechanisms for certain diseases or cellular functions that are being studied in space, we actually learn about how they act in normal gravity conditions. So we might think that a certain pathway or activity is driven by, let's say, molecule A, but then when you take away gravity, you see all the other different players that are affected by that pathway. So a lot of what we learn in space, we can extrapolate back to the Earth environment of 1G.
Oh. So is this type of information shared back like with the National Institutes of Health and
Yes.
people like that?
Yes, so a lot of them are funded by the National Institutes of Health. There's publications that are available to the public in academia. There's also a specimen sharing program at NASA Ames Research Center, where they have plants that have been to space, and people from universities can write proposals to potentially use that sample in their own research.
Wow.
So there's a lot of sharing going on in collaborative science, which is very interesting to see and hear about.
That's fascinating. Now, Jordan, we're going to switch over here, and I'm going to see if I can ask a question that I'll pretend that I might understand. So among other things here, investigating genetic responses to space radiation exposure in bacterial endospores, utilizing computational methods to elucidate changes in genome sequence and methylation patterns. I have no idea what that is. So now you've got a job to explain it to a layperson like me and to those like me in the audience.
Yeah, absolutely. So when we send spacecraft into space, we know that they're not completely sterile. It's actually really, really difficult to remove bacteria from anything on Earth, just because microbes are everywhere and they're very ubiquitous. And so we know that when we send things to other planets, other moons, deep into space, that we're actually bringing life with us. And so we want to know how well these things are actually surviving, because it is possible that the UV radiation is killing a lot of them, but there is also a potential for survival. So the bacteria that I'm working with were flown on the International Space Station for 1.5 years, and we're currently doing post-flight processing, and we're looking at how the genomes have changed over the process of their spaceflight and return to Earth.
I think I know what you're talking about. That's it. Okay. This is interesting. So you've investigated Martian Regolith, I don't know what that is, simulant shielding of bacterial spacecraft contaminants from UV radiation. I think that's sort of a carry-on from what you just explained. Right? Can you tell us what this is about again?
So that's actually really closely related to what I'm working on that I just described. This is my last summer's project. And what I did last summer was I was working with Martian Regolith simulants. Regolith is basically dust. So when we go and look at Mars, we know that there is lots of fine particulate matter, and there are frequently these really large dust storms that can cover the entire planet because it goes all over the place. And again, when we send these spacecraft to Mars, we know that there are certain microbes microbes on board. A lot of them are bacterial endospores because when certain bacterial species become stressed out, they go into this really condensed, low metabolic state. So basically they can survive a lot of things without actually doing many living processes. And so we wanted to see how well these things could actually be surviving in a Mars-like environment, and if being covered by dust or being embedded within a spacecraft or something could actually allow them to survive for longer.
Okay, wow. That's good. I'm going to go back to you, Elizabeth. I'm going to go back because these are things where I'm trying to learn a lot about here. Okay, you conducted research determining the RNA integrity number of biospecimens held in ultra-low temperature freezers to assess the effects of storage on tissue integrity. Research report has been published to the NASA Technical Report Service. Tell us what that's about.
So there's what's called a biobank, where they store tissues from old experiments. So spaceflight experiments are highly valuable, and the information that you can get from something that's been flown in space is almost invaluable. So with experiments that are conducted on the International Space Station, a lot of times the scientists are focused on one pathway or one part of an organism, and the rest of that is saved and preserved for future science to be conducted on it. So if you have a plant and you're only interested in the roots, the rest of that plant will be stored in ultra-low temperature storage for another scientist to come write a proposal and possibly look at the effects of spaceflight on a different system. So what I did was I took tissue samples and determined the RNA integrity number. So that's a measurement of how well the RNA has been preserved if it's been degraded over time.
What is RNA?
So RNA, DNA is like the full instruction manual. So that'll have all of the procedures that your body will ever need. And there might be some emergency procedures, but you're not going to read and enact those unless you're in an emergency. And RNA is sort of what's actually being done. So if there is an emergency procedure, you'll know that it's being used because it'll be reflected in the RNA that's present. And so you can get a lot of information on genetic expression by looking at RNA. So that's why that was important for our study. So I looked at how well that RNA held up over time in that biobank and what kind of downstream functional analysis you could do with that genetic material.
Okay, I think I'm understanding some of that. Also, you assign searchable keywords and parameters to experimental reports from the ISS maintained by the Ames Life Science Data Server. Can you also elaborate on that?
So that's the Ames Life Science Data Archive archives the different experiments that have been conducted on the International Space Station. So part of my work was to look through technical reports and summarize what exactly was being looked at, what is important about this report, and then assign searchable keywords. So if you were to Google something, you might look up certain lyrics from a song, and Google spits back at you the song that you're looking for. And so that's kind of what I was doing, but with scientific reports. So what people would be likely to look for if they were interested in that specific report, I would try to pull out and assign those words or phrases to that report. That way it could be easier to share knowledge in the scientific community.
Okay. Well, basically, I'm saying a wow to everything I'm learning here because I feel like I'm just starting back in school to try and understand things that these wonderfully astute individuals already know way beyond me. And now we're going to take a brief pause from Interesting People with my two guests, Jordan and Elizabeth, and then we're going to come back for the second part of this interview on Interesting People.
So there you are, shuffling through a stack of resumes, and you come to mine. This is it, first impression, my way in. But can my resume show you how I truly stand out? Like that I was studying, going to night school while working 2 jobs just to help my parents pay for groceries. Or being the first one to always step up. No, that's something you just can't put on paper. look beyond the resume, and discover new ways to develop great talent that is dedicated, hardworking, and determined like me.
Welcome back to Interesting People. My name is Tom Lorentzen, the host of the program, being filmed here at Chabot College in Hayward, California. And today's guests are Elizabeth Talburt here and Jordan McKaig, both people who are just emerging in their careers and their worlds in science, and they're working for a contractor on an assignment at NASA at Moffett Field here in Sunnyvale, California. So Elizabeth, I'm going to go back on and ask you a couple questions, and you a couple more, Jordan, on things in your resume, because both these individuals here are in their early 20s, recently out of college and looking at graduate school and other things, and involved in some very scientific research. And I want to pick their brains a little bit more because I'm, again, a neophyte on science. So Elizabeth's going to go to question here, and you did a project here, or a paper, I guess, on temporal RNA integrity analysis of archived spaceflight biological samples as part of gravitational and space research. Tell us what was in this research and paper you did and what this was about.
So that was the manuscript that we wrote for the experiment that I was talking about previously, where we were looking at tissue samples that were held in the biobank. So one of the things that I think is really beneficial about science is the communication end, where when you conduct research, the aim is to have something published and to share that knowledge with other scientists. So this is my first publication, and it was a very challenging process. I think doing an experiment and writing about it and communicating clearly what you have done are two different beasts to tackle. So I think I learned a lot from writing that paper, and hopefully the information in it will benefit future experiments. And it was an important piece of information because a lot of the tissues and different samples that were being stored hadn't been touched since they were put in there, and some of the samples that I worked were there since 1991. So it's been quite a while, and I think some of the older samples are from the 80s. And even with their age, you could still get a lot of valuable information from them. But it was difficult to try to decide on how exactly to determine what kind of testing to do on these samples, because we didn't want to use up all of them or to use up too many samples in testing. We wanted that information to still be readily available for other scientists if they wanted to use spaceflight tissues. So that was what that manuscript was centered around, was how exactly does being held in cold storage affect the tissues and the availability of the tissues and how they can be used in the future.
That leads me to ask a question on something to both of you in a way. So your background is in science and mathematics, biology, etc., physics. How do you learn to communicate? Because, like, I hate to say it, engineers are not known necessarily for being necessarily good communicators. Some are as scientists, because you get deep into a world that very few of us really understand. It gets complex and deep. How do you learn how to, when you're in college and now, do you get added training or just develop on your own an ability to communicate, whether in writing or in speaking? Any thoughts on this? Jordan, you got any thoughts on?
Yeah. So I think definitely the more narrowed in on a certain field or a certain topic you get, the harder it gets to communicate it to a broader audience, just because it can be really, really specific knowledge. I have found that thinking of communicating, say I'm talking to a close friend of mine, or I'm talking to a family member, or I'm talking to myself 5 years ago who didn't know that my current dream job even existed, and just trying to think of how I would explain it to that person conversationally, and just going from there, maybe starting from the most simple things and then kind of building up into the more complex and the more involved details of the scientific work.
Any thoughts, Elizabeth, from your standpoint on communication, writing or speaking? And
I think I present to my family a lot before I go to a conference or before I have to do like a oral presentation, and them asking me questions on, well, what does that mean, or can you explain this a little bit more, I think helps a lot. And whenever I'm prepping for a presentation and they're not around, I try to think what kind of questions they would ask. And a big piece of advice would be to try to avoid using jargon. So there are certain technical words that you could throw around that mean a specific process, or you could just describe what the process is. So instead of using the big vocabulary word, you can just explain in normal English what the process that you're investigating is. And I think that helps a lot with understanding the why and the how of the research.
Well, I know the most important thing I learned about gravity is that it works. Beyond that, I don't understand much beyond it, but it does seem to work and does seem to happen. Going to go and ask you another question here, Elizabeth. And you designed and built the electrical hardware for the group high altitude balloon project, as well as conducted analysis of the data recorded by the payload. Explain that to us.
So for SLSTP, the Space Life Sciences Training Program, there is a group project component of it, and in the summer of 2018, our project was a high altitude balloon. So we flew what was somewhat of a weather balloon up into the stratosphere, and at certain points we did atmospheric sampling. There were a lot of wildfires, some pretty devastating wildfires, and we were looking at the smoke and the particulates from that wildfire, and if there were any microbial associations with that smoke. And my portion of that project was to design the hardware. So we had these trays that would be deployed at certain altitudes, stay outside to collect samples from the air, and then come back into the payload and be quarantined off and shielded to preserve the sample. And so I designed the arms that came out and went back in, and that was done like with an Arduino and other like microcomputers that were on our payload.
Okay, and back to you, Jordan. Just last year, you did a talk and a poster presentation to the American Society for Gravitational and Space Research. So what did you talk about? What was your presentation?
Yeah, so at that conference last year, which is abbreviated as ASGSR just for simplicity, I presented on my work that I did at NASA's Ames Research Center last summer, and Elizabeth and I both presented at that, and we both actually also ran for and became part of the student board. And so we have some responsibilities as associated with that, including doing outreach activities for people in different communities and also doing political advocacy. So we journeyed to Washington, D.C. last spring, and we talked with some different people on the Hill and talked about the importance of funding space research. And at that conference also, there was lots of really great networking opportunities, and it was the first time I could really present my research to people from lots of different fields on this really cool platform of people from all over the country that were interested in space and gravity. What
do you think that the public, and I'll put myself there and the people in the audience here watching this, what do you feel are there things that come to mind that you feel the public needs to know about the type of research that's going on in your area at this time, looking towards the future? What things do you say, well, you should know about this, for better or for worse? Any thoughts come to mind?
I think a big one is that the science that is going on, it works, and the results that are being communicated are pretty well validated. And there's a lot of speculation and distrust surrounding what certain groups will sometimes put out about science, but at the end of the day, the main goal of science is to advance human knowledge and to advance human progress. And so there's all this really, really cool stuff that is being done to really understand our place in the world, our impact on the world, and what sort of things we can do to harness the capabilities that we have in order to advance our civilization.
Okay. Do you feel that it's been said that music is an international language, that Mozart, Beethoven, Elton John, that this is universal appeal, or if you like certain types of music? Is science a similar thing? Is this a form of international language, and where do you see science at this time and going relevant to looking at other nations around the world? Not only what we're doing here, but what other nations are doing. Do you have any thoughts you can share with the audience and myself on this?
I forget which movie it's from, but there was a quote that math is the same in every language.
Okay.
And I think scientific research is done on an international scale, and a lot of institutions share their information or do literature reviews, and they read papers or about the research that is being done in other countries, and that helps build the research that's being done here in the US. So I think science is sort of this international collaboration. When we went to the moon, there was this emphasis on using the greatest minds in the world to get there, and I think that's kind of the spirit of the International Space Station too. It's not just the U.S. We share that space with different countries, and there's collaboration in that. And I think that it's really important, and that it is a uniting factor to have these breakthroughs, and especially if it has to do with human health, then that's something that could potentially better people as a whole, not just one specific country.
Mm-hmm. I'm going to ask you a question if I have it. Well, here it is. Folks, I've got one of these things, and I have a laptop, I have an iPad. This all came later in my life to learn these things and how to use them. You were born with these things. So people of my generation, younger than me, older than me, look at all this stuff and say, what the heck's going on here? And there's a lot of good, obviously, that comes from this, and things that concern people. You were born in this world where these things are present. What are the good and bad that you see about our emphasis on technology and iPhones, iPads, the internet, Google, things like that?
Yeah.
What thoughts come to mind? You're young people.
Yeah. Well, so there undoubtedly is both good things and bad things associated with having all this information and all of this computing power available to us. And it really can be sometimes a cause for concern when you look at things with, having this technology always being plugged in can sometimes interfere with the way that people interact with the world or the way they perceive the world. But at the same time, it is this incredibly powerful tool. Like, we have so much information constantly at our disposal, and it's really, really powerful, and it's just important to know how to use that power, because it can do a lot, but it can't do everything, and just wielding that power responsibly.
What thoughts do you have, Jordan, about growing concerns on privacy and in identity theft, which a lot is going on through this world? What thoughts do you have? What are your concerns, and what do you feel comfortable about and uncomfortable about?
Yeah, I think one of the big concerns is just what the general public knows about what computers can and cannot do. So we grew up in a time knowing that we were kind of raised to assume that anything put out on the internet is permanent, it's not going away. And also you kind of have to develop this capability for starting to figure out, like, this news source looks credible, this news source doesn't look so credible, and just being aware that there is certain things being put out there on the internet that might not always be the most true. And so I think that's definitely going to be a really big thing that needs to be addressed going forward, just to make sure that, again, everyone is using this technology as responsibly as possible.
What thoughts do you have, Elizabeth?
I think privacy is a big concern for a lot of people. I know for myself, privacy is a concern. I like to have the policy of I don't want to post anything on social media that I wouldn't want my parents to see, and I think that's helped me out. I think some generations take for granted the fact that when they were younger, if they made a mistake, it wasn't published to the internet, whereas a lot of young people now going through middle school, high school might post something on the internet that at the time seemed funny, or at the time was a joke with their friends, but later could come back to haunt them, because as Jordan said, once something is on the internet, it pretty much stays there. So privacy is definitely a concern. What people post themselves should be a concern, and how much of what you post is private or how much what you look up, it's hard to say and hard to gauge how much of that is private. So I think there are a lot of advantages to this technology, and I do use it myself a lot. And I think that
Good.
I think that the technology available to us is a great advantage, but we do have to use it with discretion.
Okay, sounds good. Well, with that, we're going to take a pause now for a public service announcement and then come back for the last 15 minutes of our conversation here today with two very bright young people from the scientific world.
Jeff Foxworthy here. You know, if you've ever found yourself repeating the same thing for 75 years, you might be Smokey Bear.
Only you can prevent wildfires.
Well, thing is, there's a lot more to say. Like if you've ever found yourself burning yard debris and then walking away, well, you might be starting a wildfire. So for the love of the outdoors, go to SmokeyBear.com to learn more about wildfire prevention.
Welcome back to Interesting People. My name is Tom Lorentzen, the host of the program, being filmed here at Chabot College in Hayward, California. And my guests today are Elizabeth and Jordan, and we're going to go back to the interview. Jordan McKaig and Elizabeth Talburt, both with a contractor doing work at NASA for the time being, then they're going on with the rest of their lives from here. We're having a subject about science, technology, the way they look at the world at this point in time, with you both being young people. We just started to talk about some of the questions about technology and concerns, and we know obviously what technology does. Does the subject of art, what comes to mind when the subject of artificial intelligence comes in? With all these incredible advancement in technology, what impact do you think this is going to have upon human behavior in the years and decades ahead? Do you have any thoughts, Elizabeth? Do you have anything you care to share with the audience and myself on this?
I feel like it's already a hotly debated topic. There's a lot of applications that could benefit from AI. You could even potentially automate certain laboratory processes if you use AI and machine learning. It's not my field, but I'm very interested in seeing what sort of applications come up within the next few years and in the next decade. I heard about a year ago that there was a company that was developing artificial intelligence to develop artificial intelligence. Oh. So if you had a certain parameter set that you wanted an artificial intelligence to do, then they would somehow deliver those parameters to their AI, and it would create an optimized AI for that application. So it's kind of cutting people out of the equation, but it's so impressive, the applications that this technology can have. I think it's a little bit intimidating for some people, especially those who aren't familiar with the field like myself, but it'll be exciting to see what sort of ideas and sci-fi applications come out of that field.
And I might have mentioned earlier, when I was younger, I didn't like to read science fiction, and my friends growing up, they all read science fiction, and they asked me why I didn't. I said, well, I'm afraid it's all going to come true, and it's here now. And so I didn't read it. But any thoughts on artificial intelligence yourself, Jordan?
Yeah, I think it's definitely, it's not going anywhere. It's going to be a really important part of the future of humanity. And although it can be kind of scary because it is this really cutting edge technology that has lots of potential and maybe stuff that we don't actually foresee being a consequence later down the road, I think that people will kind of adapt their behaviors in order to optimize it. People are pretty good at adapting to changes and kind of hopefully eventually taking things in stride and eventually benefiting from them.
Where you're particularly focused on science and space applications biologically and other things, where do you see science and technology going in some other areas, like perhaps transportation? Any thoughts on where younger people, they say now, are not buying cars like they were? Hot rods were the big thing when I was younger. Mm-hmm. Now people are driving less and they're using other forms of transportation. Where do you see science and technology going, and where do you think people, how will they be behaving to get around? Will transportation look dramatically different 50 years from now when you're my age? What do you think's going on out there? Any thoughts?
I think it's definitely going to be a really exciting future to keep an eye on. And in terms of people using technology in their own lives, it looks like people are getting a lot more empowered and understanding the tools at their disposal. And you see more people being able to learn skills without necessarily having to go and get a formal education. For example, you could teach yourself how to program a computer using the internet without ever actually going to a computer class. And so I hope in the future to see people really understanding what they can do and having more scientific literacy and using all of that in order to accomplish their goals.
Now, in going through college, and I know you may go back to graduate school, you're in the area of science, so you take mathematics, science, biology, chemistry, physics, etc. What about the social sciences? Did you take classes, and was there any interest that you had in the social sciences, history, sociology, political science, literature, or what? Any thoughts come to mind? Go first, Elizabeth.
Yes, I took a couple, I took a political science class, which I really enjoyed, and it made me pay attention to the news and seek out current events, which I guess I hadn't really been doing because I was so focused on my classes. I was isolated in the news of science or my engineering classes. So having coursework that's outside of that subject, I feel like is beneficial to keep you a well-rounded person. And I really like art, so I took some art classes and a few writing classes. I think in another lifetime I probably would have tried to pursue writing or painting. I think having artistic literacy is as important to me as my scientific literacy, just to stay engaged with that creative side and apply that creativity to my work. And I think painting and drawing and even writing has helped a lot with my scientific career. I think the art with the spatial awareness and the writing with being able to effectively communicate what I'm doing.
That's interesting. Artistic literature. What about yourself with social sciences,
Yeah.
Jordan?
So when I started college, I was interested in biology, but I wasn't totally committed to the idea of staying in STEM. So because of that, I did some exploration in some different classes in social sciences and humanities. And I ended up actually graduating with a second major in international studies. And in doing that, my main concentration was health and environment. And that taught me a lot about just how big decisions are made on higher levels that can influence things for lots of people across space and time. And so that was really, really interesting for me. And that's something that I've definitely started to think a lot about as I begin trying to go into the space industry and learning from the people at NASA and just kind of thinking about the different sorts of political things that are going to come about in the future. Like, for example, who's going to be in charge of making laws if we have a settlement on the moon? Like, who's in charge of that? There's just all these interesting questions that aren't really fully answered yet.
You know, when you mentioned about politics too, Albert Einstein, who, you know, he's still holding up well after some of his original ideas and writings going back 100 years ago. But he was once asked a question about, or asked, why don't you get into politics and run for office? And you know what his answer was? He said, it's too complex for me to understand. And I've been in and out of the political world, been interested in history and science, and stuff is too complex for me to understand in so many ways. But do you find the political world and the world of history of any particular interest you other than its relevance to science?
I think it's really helpful. Yeah, I think just as Elizabeth said, it's important to have a well-rounded perspective on those kinds of things. So, for example, history can tell us a lot about why things are the way they are right now and what sort of problems can arise in certain circumstances so that you can work to hopefully mitigate some of those issues. And obviously you won't be able to predict everything, but it can offer a really valuable perspective on the way that people might approach different situations.
Mm-hmm. On a sort of a contemporary note, there's more and more questions being raised and concerns publicly, and including in our nation's capital and elsewhere around the world, about the role of these high technology companies like Google, Facebook, and other ones. What thoughts do you have? You've grown up in this world where they're there, and we use them, I use them. What's the good and the concerns you have both? What comes to mind on these, Elizabeth?
I think some concerns that I view personally are just concentration of wealth. I grew up in the Bay Area, and it's a little bit intimidating to think about purchasing a house in this area with the current housing market. And a lot of that has to do with the tech companies that have flocked here, and it's a double-edged sword, because on one end, it's extremely valuable to the job market in this area. They're aspiring engineers and scientists like myself who want to be employed by these big companies, but it's also raising the prices and the cost of living around here for normal people and for people that want to be in the engineering and science field as well. And I think that's one concern, is the concentration of wealth. But on the other end of that, there are these amazing technologies coming from those companies that are beneficial to all. And I think as we progress with technology, it'll be more readily available to people. And I think in the beginning, with new technological developments, a lot of it is more expensive, but as it becomes more commonplace, then that price goes down, and you can have these technologies available that are great for education, for quality of life, that are more readily available.
What trends do you see coming from your perspective here? It's 2019 and you're 22 and 23, right?
Mm-hmm.
Trends in science and technology. What are the trends that you see that are being birthed now or accelerating? What trends do you see that you think are going to be important in the next 10, 20, 30, 50 years? Anything stand out in your mind, Jordan?
Yeah, so this is partially because this is what I'm interested in, and it's a career, but I really do think that the future of space science is going to really focus on habitability investigations and life detection, just because people are all thinking about, oh, like, how can we go to the moon? How can we go to Mars? And I really hope that we see a lot of really cool exploration of the different planets and the different moons around us, just because there is so much to learn, and it's so difficult to get information about this far off place when all you have is, like, a robot. And so I really hope that as we go into the future, we see lots of just these really miraculous discoveries that help us understand who we are, how we got here, what our place is.
Now, when I was your age, I can remember I was 23, your age, and you're 22. When Apollo 11 happened and we landed on the moon, it still stands out in my mind. So, do you think we'll be on Mars in your lifetime?
I think we will be.
Yeah.
I think we will be. NASA has a big push to go to the moon in 2024, and I think that's the next big step before we go to Mars. We're sending new rovers and technology to Mars in 2020, and I think that's sort of the precursor to sending people there. Is, well, what are our instruments doing? What can we collect and be more knowledgeable about on Mars before we send people there? So I'm hopeful that we will be on Mars in our lifetime.
And what do you think?
I hope so.
I hope so.
Yeah, I think the motivation is definitely there, and I think with all the technologies, like Elizabeth said, we have stuff that is launching next year, and the Mars 2020 rover will be equipped with all this new stuff, and we'll get this data that we've never before seen about the surface of this planet. And I think the results from that will really feed into what happens with hopefully sending people to Mars, just because depending on certain things, we might find something there that is a concern for human exploration, or we might find some sort of resource that could actually be really useful. So it'll be definitely really interesting to watch.
And what are the two of you looking towards at this stage? You're in your early 20s, you're just starting your careers, you're continuing on with your education. Where would you like to eventually end up, any particular place, area, in terms of your professions, your careers working? Would you want to come and be at NASA, or would you want to be somewhere else? What thoughts do you have, Elizabeth?
I think ultimately I would love to be an engineer at NASA. I've had intern work there for 3 summers and just kind of fell in love with the research and the culture that's going on there. So hopefully in 10 years I'll be an engineer for NASA, hopefully working on the interface between engineering and biology.
What about yourself, Jordan?
Yeah, I would really like to work at NASA. As I previously said, I'm really interested in solar system exploration, and NASA is really the place to be for that kind of thing. And so I hope that in the future I'll be involved in kind of the mission planning, and I'm also really interested in the policy that sets how these things can be done and how we can communicate the results to people that might not be as in tune with it.
And now, at your young age, what advice do you have for other people your age and younger who might be interested in education and careers in science? Anything, advice you can have for them who are listening to this program?
I would say that it's important that if you have a passion for something or an interest in something, to go for it. You don't have to be perfect at math or science to be in the math or science field. As long as you have that interest, I would say to pursue it. Life can take you in a lot of different interesting directions that you wouldn't expect. Like I said in the beginning, I kind of came into this career upon happenstance by noticing a sticker and liking the design of a sticker, and it led to this world of opportunity and opportunities in science. I'm also somewhat of a non-traditional student, as I'm a military spouse, so my husband is in the Army, but even with that, anything is possible, and I would say no matter the circumstance you're in or what your background is, if you have a passion for a certain career, then to pursue it, and you owe it to yourself to pursue it.
And Jordan, what advice do you have?
Yeah, I would definitely say don't be afraid to go after what you're really interested in. There's just so many things. There's a whole universe, quite literally, of things waiting to be explored and discovered. So don't be afraid to go out there and see what you can find, and always just kind of keep your eyes open for new opportunities. For example, if you told me, even 4 years ago what I would be doing now, I would be shocked because I didn't know that this line of work even really existed and was a possibility for someone with my interests. And so just go out there and see what you can do.
With that said, we're going to wrap up this program, and thank you for the audience for you listening to the program, and thank you, Elizabeth, for being on the program today.
Thank you.
And thank you, Jordan, for sharing all your experiences that you've had at such a young age, and for sharing your knowledge and giving your advice as we look forward to the future and probably landing on the Mars in your lifetime. Thank you.